A very good morning to all of you. Here we are again meeting with another topic of mathematics, application of trigonometry, heights and distances. Now, before we go on to that, I would like to mention this is our 25th series of the CISC virtual series. And it's wonderful to be connected with students and children with topics, different topics, and learning both for teachers and students. And there has been a very well feedback, good feedback from all parts of India and abroad of these topics that has been done both for ICSE and ISC. So let us go on to what we are going to do today. Again, a very good morning, students, teachers, and all the viewers. Our topic, application of trigonometry, heights and distances. Now, we have already done the topic on trigonometry identities. Now, trigonometry, how it is applied in our daily life. So we are going to do that. Now, lesson content. So what we are going to deal today with, first, let us recollect certain basic concepts. Next, what is trigonometry and how is it useful to us? Then we have our trigonometric tables. We'll learn of using trigonometric tables, that is the tables that is provided from in the mathematical tables. And also we will be discussing certain basic application of trigonometry. So these are the discussions that we have today. So our main topic is heights and distances. Now, before we go on, so let us see what is trigonometry. Trigonometry is that branch of mathematics that studies between the sides and angles of triangles with the relevant functions of any angles. So it's a study between the lines and angles, both sides and angles of the triangles. So that is the first basic concept. Then it is dealing with measurements of sides and angles of right angle triangles. You have seen that whenever we are dealing with our trigonometry, we are dealing with right angle triangles. Now, if I ask you, where do we use our trigonometry? Where to use trigonometry? How is it important? And your first answer would be mathematics. But actually speaking, trigonometry use is very vast. Application is far and wide, and right from ancient times, there are a lot of application of trigonometry. Now let us see some real-life application of trigonometry. Trigonometry is used to measure heights and distances of trees, buildings, mountains, etc. Then it's applied in architecture. You start thinking, how is it applicable in architecture? Then we have the application in astronomy, a vast use in astronomy. In marine engineering and flight engineering, we cannot do without it. In navigation, we have it in criminology, music, we have it video games, all the video games that you all play, its application, trigonometry is applied there. Cartography. So these are just a few applications that I have written here, and you can search more and find out more about them and see how trigonometry is used. Then you'll feel satisfied that you are learning trigonometry. Now, next is our recapitulation of trigonometric ratios. The whole trigonometry is based on these trigonometric ratios. We have done it in class 9. We have done when we were doing identities. Again, we need to brush it up. So, whenever we are speaking about the trigonometric ratios, we have the concept of our right angle triangles. So, when we are speaking about the right angle triangles, what do we have? We have the right angle triangle, and then we have what do we say, the perpendicular, that is the angle opposite to the theta, that is the whatever the angle we are taking. Say if this is theta, this I'll take it as perpendicular, the side adjacent to it. So this is your base, and the side opposite to the right angle is always the hypotenuse. Don't make a mistake. Hypotenuse is the side opposite to the right angle. Now, these are the ratios we have already done. Quickly I'm brushing through, and you also have a look, because without this we cannot proceed. So sine theta is what? Perpendicular over hypotenuse. Cos theta base by hypotenuse. Tan theta is perpendicular over base. And cosec theta is reciprocal of sine. So if I know sine, I know cosec. 1 by sine theta. Sec theta is reciprocal of cos. 1 by cos theta. And cot theta is reciprocal of tan theta. Vice versa, tan theta is 1 by cot theta, or cot theta is 1 by tan theta. So these ratios are the key word for trigonometry. So two keywords, one is right angle triangles, and then the trigonometric ratios. Now, trigonometric ratios of standard angles, these has been reduced, and we know the values. The standard angles are 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. And the ratios are for sine, cos, tan. If you know sine, cos, tan, automatically you know your sec, cosec, and cot, because they are just the reciprocal. So these values you must know, because we are always going to use them in our sums. Now, when we were speaking about the standard angles, there was only 0 degree, 30 degree, 45 degrees, 60 degree, and 90 degree. But what about the remaining angles? So between the 0 and 90, we have all the other angles. So this is how the table is. Now there are, in your tables, you'll have the minutes also. I've taken up only the degrees. So I've taken the three basic ratios, sine, cos, tan, and here it reads it. So when we have angles other than the standard angles, we have to use our trigonometric ratios from this trigonometric tables and read out the values. The values are given here. So these values, we are going to use them. Now, as we do, I'll be discussing them, how we are using it. So nothing to worry. So use of trigonometric tables. Now let us have a look. What did we see in our standard angles? Sine 0 degrees is 0. And what is sine 90 degree? 1. What did you say for cos 0 degree? 1, and cos 90 degree 0. These by this time you must be familiar with these. Tan 0 degrees is 0, and tan 90 degree is a large number. It's not defined. So now, from the trigonometric tables, what do we observe? We see sine theta and tan theta, the value increase with the increase of the value of theta. And let us see what happens to the cos theta. Cos theta, we saw cos 0 is 1 and cos 90 is 0. So is the reverse. It decreases as the value of theta increases. Now, let us have a look at our table. So I've just taken a part of the table. I haven't taken the whole thing. So certain values are shown. Now let us see. Sine 40 degree. Now when you are looking up your table, so this is sine 40 degree. Look up your table. Now this is our sine ratio. See, can you see your sine ratio? This is sine. And here we have got 40. What is the corresponding value? 0.6428. So sine 40 is 0.6428. And what is sine 76? Sine 76 is equal to, let us look at the table again. So here we have got sine 70. So we have got here 76 degree is 0.9703. So that is your value. I hope you can read the values here. So here we have got it. Sine 7. Now, let us see the next one. Cos 40. Again, Same cos 40. Let us see this. Cos 40 is equal to 0.7660. See, according to the cos column, we are looking at the value. And cos 76, let us go for the 76 degree. So degree, 76 degree, and cos value is 0.2419. Now next, tan 40. We have taken the same angle. Tan 40 is 0.8391. And what is tan 76? That is 4.0. Here we've got 4.0108. So do you see the value, what we had concluded from the standard angles here? See, sine 40 is 0.648, sine 70 is 0.9703. So this value is more than this value, and the angle 40 is lesser than 76. Now let us look for tan. Tan 40 is 0.8391 and tan 76 is 4.0. Again, 76 angle is greater, value is greater. Now look at cos. Cos 40 is 0.7660. But when we are looking for cos 76, it's 0.2419. See, this value is more than this value. So though the angle has been increased, the value has decreased. So remember this concept that for cos, the value goes on decreasing as we increase the value of the angle. So I hope this is clear. Now let us go on to, before we go on to the sums, certain points you must remember. Always when a sum is given, read your question carefully. Note down and double check the data that is given. It is very important to check the data. This will eliminate the chances of copying the sum incorrectly, because if you copy the sum incorrectly, say 83, you are writing it as 38. That means right at the beginning you have gone wrong with your sum. So you must be very careful when you are noting down the data from the question. Now for these practical application, please remember you need to draw your diagrams. And on the diagram, always indicate the data that is given to you. The given data must be shown in the diagram. So this helps to solve your problem easily because they're right in front of you. You don't have to go on looking at the question paper, or if it's from your textbook, you're doing at your textbook to see what was the given data. Always give your answer in the simplest form. So give your answer, simplified answer. Don't leave it in a long answer without simplifying. And all necessary steps of working must be clearly shown along with the answer. So this is a rule for when you are solving, even in the board examination, your paper, you are solving it out. Remember, all working, even if it is a rough work, you make a rough column on the right hand side, and all working must be there. So no one is going to look back in the back page where you have done your working. So it must be along with the answer sheet. So application of trigonometry, we are going to do a sum on this, applying trigonometry. Using trigonometric ratios, evaluate the values of x and y from the given diagram. So a diagram is given, very important diagram I told you. So the diagram is given and this is what we have got. Now look at the diagram, study the diagram. What is it? A right angle triangle. ABC is a right angle triangle. Two sides AB and BC is given as x and y, and the hypotenuse is given to be 500, and one angle is given to 60 degree. So there's no other way we can find out unless we use trigonometry. We know one side, we know one angle. We have to find the remaining sides of the triangle. So what do? We use a trigonometric ratio. Now you have to understand which ratio to use, sine, cos, tan. Now I need to find out x. So first ratio that we need is to find out x, and I know what the hypotenuse. So perpendicular and hypotenuse involved, what is coming into your mind? The ratio I need to use is a sine ratio. And when we are doing the y, it is the base and we know the hypotenuse. Which ratio? Base and the hypotenuse, that is the cos ratio. So this is how you are going to ponder over the question, see the diagram and think what you are doing. Now let us solve the sum. So ABC is a right angle triangle, sine 60 degree, as we said just now, perpendicular over hypotenuse. Now sine 60, we need our standard angles. So here I've brought in, you are supposed to remember or make your own table as I had shown earlier. So sine 60, this is our value root 3 by 2. So we'll substitute the value root 3 by 2, that is equal to x by 500. So all the given data, I'm looking at my diagram and I'm substituting it. And x is 500 into root 3 by 2. Now, what is the value of root 3? We never leave our answer as an irrational number. So, root 3 is 1.732. You won't be given that value. You are expected to remember the value. So, 2 cancels with 500 and we get 250 here. So, therefore, what are we getting here? So, 2 and 500 cancels. We've got 250. So, therefore, our answer is coming to 433 centimeters. So, x we have got. Now, let us see our y. Cos 60, base by hypotenuse. Look at your values. You have to remember cos 60 here. The value is equal to half is y upon 500. So therefore, y is 500 by 2 and we cancel. And there we have got the value of y equals to 250 centimeters. So we have used our trigonometric ratios to evaluate the unknown size of the right angle triangle. Now let us go on to another problem. Now, first and foremost, what are you supposed to do? Read your question carefully. So, we are reading the question. A ladder leaning against a vertical wall makes an angle of 60 degree. Now, see this, I've used another color for 60 degree. Why? The points that you need to remember when you're reading your question, the data that is given. 60 degree with the ground. The foot of the ladder is 4 meters away from the wall. So there's another data given, 4 meters away from the wall. Find what? The height of the wall, the length of the ladder. So before you can proceed with this, you cannot proceed unless you have your diagram. So let us draw our diagram. So we have got the vertical wall. We have got a ladder leaning in it. You don't have to draw the ladder. So we can draw the hypotenuse and we have got the base. So a ladder is leaning against the vertical wall and we have got a right angle triangle. See the right angle I've drawn, and let's name the figure. It becomes easier to work and we are putting in the data given. What is the data? Base BC is 4 meters given and the angle is given to be 60 degree. And we need to find the height of the wall, that is AB. We need to find the length of the ladder, that is AC. Now let us go on to solving the sum. Now we have got a triangle and it's a right angle triangle. So since I'm going to find now AB, the height, and I know the base, I'm going to use my tan ratio. So tan 60 is perpendicular by base. So just logically go on thinking, what do I need to find out? Then if I know this, what am I going to use it? Just go on asking yourself this question and you'll find out it becomes very easy to solve it out. Tan 60 is equal to AB by 4. So because I know 4 and I don't know AB, but I know the angle. So again, tan 60, we have seen it in the table, it's root 3, AB by 4. So AB is equal to 4 root 3. Now remember, we do not leave our answer as an irrational form. So we put the value of root 3 and what is our answer? AB equals to 6.928 and that is the height of the wall. So we have got our first part. Second part, we need the base is known to us, and we need the hypotenuse. Base and hypotenuse, I said just now, it involves cost ratio, base by hypotenuse. Now put the value. Cos 60 is half and base is 4 and AC. So we get the length of the ladder AC is equal to 8 meters. So again, full application of trigonometry to find something like a ladder and the height of the wall. Let's go on to the third sum. So during the cyclone Amphan, you must have heard about the cyclone and some may have experienced it also. In a certain locality, a tree breaks in such a way that its top touches the ground and makes an angle of 30 degrees. So again, I've seen that other color I've used. So that is one point which you need to note when you are reading a question. 30 degrees with the ground. At what height from the bottom does the tree break if its original height is 15 meters, and also find the distance between the foot of the tree and the point where it touches the ground. So there are two things we need to find out. Now, again, there is one part which you must be very careful about. In many cases, in examination also, you all read this, but then you forget after you finishing the sum. So remember, if there is some rounding off given, you must make a note. So here I've underlined, you can underline it, that's so that you remember, and here I put a different color. So two significant figures. We'll come back to it afterwards when we come to the end of the answer. So here is a tree broken and it's fallen onto the ground at a certain height. And now to solve it out, we need a right angle triangle. So let us form a right angle triangle. So this is our right angle triangle, A, B. So we have got the right angle triangle, and the angle made with the tip and the ground is 30 degrees. So here we have marked it as equal to 30 degrees. So this is 30 degrees. Now let us solve it out. Now what are the things we need to find out? We have to find from at what height from the ground it has broken. That means this AC I need to find out. Sorry. And we need to find out our AB. So therefore, we proceed to do it. Now, since we know the angle C is equal to 90 degrees, but here we don't know any of the sides. So directly I cannot use my ratios. But I know that AC plus AB, because the total height of the tree is given to be 15 meters. So AC plus AB is equal to 15 meters. So therefore, let us write down the ratio. Sine 30 is perpendicular over hypotenuse, AC by AB. So sine 30 is AC by AB. Now sine 30 is equal to half from our standard angles, because this is a standard angle. AC I know. I'm going to find out AC. So I cannot have two unknowns. So AB from this given data. So from here I'm writing AB is equal to 15 minus AC. So therefore we get here, simplifying. So therefore AC is coming to 5 meters. So height from the bottom at which the tree breaks is 5 meters. But we have got another part to it. So let us go on to the next part. So we have to find out the distance BC. So tan, because I've already found out the AC, the perpendicular, so we'll use the base BC. So tan 30 perpendicular over base. So tan 30 is equal to AC by BC. So tan 30 we know 1 by root 3 equal to 5 by BC, because 5 meters we have already found this out. 5 meters. So therefore we have got here ABC 5 root 3. We don't leave it in an irrational number. Substitute the value of root 3. Multiply BC equal to 8.66. Now, we have got something more. There was a rounding off. Don't forget that. So, we have to round it off to two significant figures according to the problem. So, for significant figures, we look from the whole number part, 8.6. From till here, we have got 2. But you have to look for the next digit, that is 6. So, 6, 5 or more than 5, we add a 1 to the previous number. So, 8.7 meters, correct to two significant figures. So, go stepwise and you'll find out that you can easily work out the sums on heights and distances. Hence, the distance between the foot of the tree and the point where it touches the ground is 8.7 meters. Now, let us go on to another sum. A contractor is instructed to install a slide in a children's park. The length of the the length of the slide should be of 4 meters and inclined at an angle of 55 degrees. Find the height of the slide correct to 1 decimal place. So there is a contractor who is instructed to make a slide in a park, and the length of the slide is already given. So it's fixed, they're bringing the. So an inclination with the base, that is also given. We have to see what should be the height of the slide to satisfy this condition. So let us bring our diagram. So there we have a slide. You don't have to draw the slide. You can draw your right angle triangle. So this is our right angle triangle for solving out the problem. So 55 degree, enter the data that is given. That is the best way to work out. So 4 meter, the length of the slide is given already, and we need to find the height. So let's name it as x meters. So the height is taken as x meters. Let the height of the slide be x meters. You can say here x meters. In the right angle triangle, as shown in the diagram, we have sine 55, because perpendicular and hypotenuse, we use our sine ratio. Sine 55 is perpendicular by hypotenuse. Now, what do you note here? This is not our standard angle. So we need to look into our trigonometric tables to find the value. Otherwise, we cannot solve the problem. So sine 55 is x by 4. Let us bring our table. So here we have got a sine 55. See, note here, sine 55. So now look for, it's the ratio value is for sine. So sine is 0.8192. So here, just look along the sine column and the degree is 55 degree. We substitute the value. Here we have got it. And we multiply by 4 and our answer comes to 3.2768. But we cannot leave our answer like this. Have a look again. Don't forget 1 decimal place. So x equal to 1 decimal place. So 3.2, that is 2 is, the next number is 7 greater than 5. So we round it off and we've got 3.3 meters correct to 1 decimal place. So the height of the slide has to be 3.3 meters. Quite a steep slide, I must say. So height of the slide is 3.3 meters. Now, practical application of trigonometry, heights and distances. To measure heights and distances. In everyday life, we can see all around us mountains, trees, monuments, and we can measure all these using trigonometric ratios. Now, when we use trigonometric ratios, now how do we go about it? So first, some basic terminology that we need to know. One is line of sight, one is angle of elevation, and next is the angle of depression. So these are some very common terms which we need when we are applying trigonometry in different measurements of heights and distances. Now, Have a look. We have got a flagstaff here with our Indian flag flying high, and a person is standing here, and if he looks straight, this is his horizontal line. This line we call the horizontal line. Like if you look straight, this is a horizontal line. The moment you are looking at something higher up, the line of sight is upwards. So this line, when you're looking upwards, we call it the line of sight. Now again, in this figure, here the man was looking at the top of the flagpole, and here the man is looking at the base of the flagpole. Again, his horizontal line is this, and his line of sight is deviating from the horizontal line and looking downwards. So he's looking this direction. So this is called the line of sight. So therefore we have line of sight is the line joining the observer's eye and the object observed. Hope this is clear. This is the first basic concept of angle of elevation, angle of depression, and line of sight to work out sums on heights and distances. Now, next terminology we had was angle of elevation. Now, let us see what is angle of elevation. So, first, say a person is standing below on the horizontal base, and he's looking at a aeroplane. So his direction from the horizontal line, his direction is moving upwards. So he's moving on this side. And then, so his line of sight is upwards, what we were saying just now. And then the angle made with the horizontal line and the line of sight, I've named it as theta. And here we have the angle of elevation. So theta is the angle of elevation. His line of sight and the horizontal line, the angle made is the angle of elevation. Now let us see what is angle of depression. So a girl is standing on the terrace of a building, and there is a car coming in and parked there. She is looking downwards. So her line of sight is in which direction? Downwards. So this was our horizontal line. So this is her horizontal direction of observation. And now to look at an object below, she has to look downwards. So this is our line of sight. And so we are naming that line, angle, with the horizontal line and the line of sight as theta. And this is our angle of depression. So you've understood angle of elevation and angle of depression. Let us define the two. Angle of elevation, the angle between the horizontal line and the line of sight, which is above the observer's eye, is known as the angle of elevation. And what is the angle of depression? Angle between the horizontal line and the line of sight, which is below the observer's eye, is known as the angle of depression. So I hope it is clear. The three terminology: line of sight, angle of elevation, angle of depression, even the horizontal line, which we have discussed. Now we are going on for a sum. Find the angle of elevation of the sun. So we are going to find the angle of elevation of the sun when the shadow of a 30-meter long pole is 10 root 3 meters. So the pole is also given, and the length of the shadow is also given. So we have to find the angle of elevation. Let us draw the diagram. So here we have got a pole, the sun, angle of elevation we are going to see. So this is our angle of elevation. So theta, let us name the figure and enter all the data that is given. I've said whenever solving problem, enter all the data that is given to you on the diagram itself. And we have marked the 90 degree as a right angle triangle. So we've got a right angle triangle. We have to find theta, the angle of elevation of the sun. In triangle PQR, tan theta equals to PQ by RQ because it's a tan, perpendicular by base. Put the value 30 by 10 root 3. So tan theta equals to 3 by root 3. So therefore, now 3 we can write it as root 3 into root 3. You all know this. And we cancel 1 root 3. Tan theta equals to root 3. Now, let's look into our table. Now, this is the reverse process. Now, here we know the value. We have to find the corresponding angle. So, go for tan ratio. Look for root 3. So, where is root 3? Here. Here is root 3. And the corresponding angle, see that column, is 60 degree. So, my answer comes theta equals to 60 degree. So, we can, if we know the size, we can also find out the angle of elevation. Now, next sum, the shadow of a cliff when the angle of elevation of the sun is 30 degree. So, we know, see what are the things we know. Elevation, the angle is also given 30 degree, is found to be x meters longer than when it is 45 degree. If the height of the cliff is 500 meter, find x. The shadow of a cliff and the angle of elevation of the sun is 30 degree is found to be x meters longer than when it is 45 degree. If the height of the cliff is 500 meter, find x. So let us look at this figure. Again, no need to draw the cliff. Draw your right angle triangle. So we have got our right angle triangle. So our right angle triangle. Now let us enter all that we know. Height of the cliff is 500 meters. So where is our height of the cliff? So this is 500 meters already given to us. Now the angles are 30 degree and 45 degree. So the shadow, so 30 degrees and 45 degrees. So this is our 45 degree. This is 30 degree. So this is 45 degree. You'll say, be careful about these angles. So this is 45 degree. This is our right angle here. This is the foot of the cliff. The closer the point is to the foot of the cliff or to the foot of the perpendicular, you can say it is the angle is a greater one. The further it is moves away, then the angle is lesser than this. So therefore, this is not 45 and 30. Please remember, this is 30, 45. This is again a very common error that we find in examination papers. Be very careful. When you are doing it quickly, you don't remember and the whole sum goes wrong. And they've said that it's found to be x meters longer. So initially with 45 degree, this was the shadow. And then with the moving away, with the angle of elevation changing, it is 30 and it is more by how much? X. So this is x. So I have to find out x, that is BC. Now let us go on to the sum. Tan 45 is equal to perpendicular over base AD by BD, that is 500 by BD. So therefore, tan 45 we know is equal to 1. So here is a value 1, substitute, and we get equal to 500 meters. Now this you can even directly do it, because if you're clear about your tan 45 1 and this is 90 degree, that means you know that this is forming an isosceles triangle. So since AD is equal to 500 meter, automatically you can write BD equals to 500 meters. So that method is also correct, just giving the explanation. Now next we go on to tan 30. Tan 30 is what? AD by CD, and equal to AD we know 500 upon CD. So therefore we get tan 30 is 1 by root 3. Look up at the table, standard table, and we have got 500 by CD. Hence CD is equal to 500 root 3. Again, we are not going to leave the answer in that form. Now, before we put the value, Let's simplify first. CB, I need to find out X. X is CB or BC, whatever you want to say. And that is CD minus BD. So 500 root 3 minus 500. So what is X equal to? CB equals to, I'm taken 500 common, you can multiply and then subtract, but these are the easier methods that I'm showing. So instead of putting the value just now, take 500 common, now put the value 1.732, 500 into 0.732, and now you multiply and you get your answer as 366 meters. So the distance BC is 366 meters. So hope you've understood. Now we have got another sum here. Anjali is standing on the top of a building of height 12 meters. So height of the building given 12 meters. She observes a red car parked on the road. If the distance between the foot of the building and the car is equal to 1 by root 3 times the height of the building. So distance between the foot of the building and the car is equal to 1 by root 3 times the height of the building. Find the angle of depression. Now it's the angle of depression. So let us draw the diagram. So Anjali is standing on the terrace looking at a car parked there, and she is looking downwards. So horizontal line, and she is looking downwards, so her observation changes, and this is the angle made with the horizontal line and her direction of observation. That is the angle of depression. Now, see, here what do we have? This horizontal line, as you can see, this line is parallel to the base. So this is theta, and this is also, I can write it as theta. You know that parallel lines alternate angles theta. So you can solve the problem by drawing the perpendicular here, or because I need the height of the building, I can take the alternate angle and work it out. So therefore, we have to find out the angle of, find the angle of depression. This theta I have to find out. So this is a line of sight looking downwards. Let the height of the building be x. So we are taking this as x just for convenience of working. And angle of depression is theta. Distance between the foot of the building and the car is equal to x by root 3 because it's 1 by root 3 times this. So this is x by root 3. So therefore we get here tan theta is perpendicular over base. So x by x upon root 3. So then tan theta equals to root 3. We cancel the x and we get root 3. Tan theta root 3, we know theta is 60 degree. So hence the angle of depression is 60 degree. So we have found out the angle of depression. Since we knew the height of the building and we knew the distance at which the point of observation from the foot of the building, so therefore we could find the angle of depression. Now, we have done quite a number of sums. Hope you have understood all the sums, and you can go back to it again and have a look, and whichever sum you can't understand, just go through it and you'll understand it. And also, please try it out, all the sums on your own. Only then, when someone explains, you can easily understand. But when it comes to yourself doing it, you might go wrong. So the more you work on yourself, then the better you will be able to solve the sums. Now let us go for the assignment on this topic on application of trigonometry. Now, please take down the sums. Question 1. Find the value of each of the trigonometric ratios using mathematical tables. So you will open your tables, mathematical tables, and look for the values and find out sine 72 degrees, cos 48 degree, and tan 67 degree. Next one, a diagram is already given to you. There are two angles here. In the given figure, AE is perpendicular to BC and length of BC is 12 centimeters. Calculate the length of BE, AC and AE. So we have got three things to find out. This is a sum which has come earlier in ICSE examination. Next one, a kite flying at a height of 75 meters from the level ground is attached to a string inclined at 60 degree to the horizontal line. Please note each of the values data that is given. Find the length of the string to the nearest meter. Next one, if 400 root 3 meter high tower makes an angle of elevation at a point on the ground which is 400 meters away from its foot, then find the angle of elevation. So here we have to find the angle of elevation. And the last question, 5, from a point on the ground at a distance of 200 meters from the foot of the tower, the angle of elevation of the top of the tower is 40 degree. So distance 200 meters, elevation angle 40 degree, which is not a standard angle. You need to look up the table, and then we need to find out the height of the tower by using our appropriate trigonometric ratios. So I hope you have copied that down. Please work out all the sums. Let us just brush up with all that we have done. We have brushed up with the recapitulation of all the trigonometric basic concepts. Then we have discussed with all the various application of trigonometry in real life. Then we have seen to our mathematical tables, which is new to you, how to use mathematical tables to find values other than the standard angles. And then we have solved a number of sums, application based, which needs the concept of trigonometry and trigonometric ratios. So I hope you've understood, and let us think and ponder over all that we have done. So remember to understand your sum. Read your sum carefully and understand it. Now we have got our next session tomorrow. So I'm just brushing up with what we have tomorrow. So first is recapitulation of basic concepts to be applied in solving problems of heights and distances. So basic concepts to be applied. Points to be noted in solving problems on heights and distances, solving different types of sums on heights and distances, and also I'm going to introduce a formula method of solving problems on heights and distances. And then a new introduction of the clinometer, which can be used to measure the heights and distances of different objects like a tree, a building, whatever you wish to, how we can use it. That also we are going to discuss tomorrow. So keep watching and be with the session. Now let us see what are the questions that we have today in our session. Here we have our first question. I'd mentioned about cartography. So someone wants to know what is cartography. So cartography is same as map making. That is, it is the study of making maps. There is even a vast knowledge about it. You can even go and search for it and find out what is cartography. The main aspect of cartography is map making. I hope you have understood. So let us see. So that means its application is in geography also, right? So let us go on, see what then our next question is. Okay, so we have come to our second question. Now let us see what the second question is. ABC is a triangle with angle B equals to 90 degree, angle C 60 degree, and BC equals to 20. We need to find out AB and AC. if we find AB using trigonometry, could we use Pythagoras theorem to find AC? Okay, let us first see. Now let us see. I'm drawing a right angle triangle. So I said we cannot do the sums without drawing a triangle, the diagram. So it's very important. So I'm drawing it nice and bold. So angle B is 90 degrees. So this is given to be B. And this is angle C is given to be 60 degree. So this is C. And what else we have got? BC equals to 20. We need to find out the triangle ABC. So what do I get here? Again, tan, because I need to find out this. This is my, so tan 60 is equal to perpendicular over base. So that is AB by base is 20. Okay, therefore AB is equal to tan 60 we know is root 3 into 20. So we are getting 20 into 1.732. So if I multiply, we get 34.64. This was meters, so this is meters. Now, if we are using trigonometry, I would have used what? I need AC. So therefore, AB, let us do. Now, see, we need B. We have got the base and I need the hypotenuse. So I'll use my cos ratio. Cos 60 is equal to base, that is BC, by the hypotenuse AC. So therefore, cos 60 degree, you know already what is cos 60? Half equal to, what is BC? BC is equal to 20 and that is upon AC. So AC is equal to 40 meters. So I've got AC by straight away by using my trigonometry. Now your question is, can I use Pythagoras theorem? Yes, mathematically you are not going wrong. So let us see. We want to find out AC. I know that AC is equal to, AC square is equal to AB square plus BC square. Now AB square. Now if you are using this, remember not to use your decimal answer. Then you'll have a huge working to do. So what we are going to use, 20 root 3 whole square plus BC square, that is 20 square. So that is equal to 400 into root 3 into root 3 is 3 plus 400. So that is equal to, we get here what? 1200 plus 400 equals to 1600. So therefore, AC is equal to square root of 1600. So that comes to 40 meters. So by working with Pythagoras theorem, you can do, but you have more working and you can use a trigonometry. So it's up to you which method you would like to use. But be careful, never use a decimal answer when you are applying it in some other part. Now let us see what is our next question. So our next question, for mathematical tables, is it necessary to know how to find values of trigonometric ratios with degrees and minutes? Now, according to the scope of syllabus, you are expected to know, you are supposed to know to read tables from trigonometric tables, both for degrees and minutes. But when it comes to heights and distances, solving the sums, you normally have only in degrees. So, but your concept must be there, how to look up your tables, both degrees and minutes from your mathematical tables, that is, which is showing the trigonometric tables. I hope you've understood. Let us go to our next question. What is the next question? Our next question. Okay, let us see what is our next question. Okay, so we have got our next question. For ratios of standard trigonometric angles, may we use values from the mathematical tables? I would advise you no. Now, why? So you will, let's say, why not? So you cannot accept it like that. So let us take another color and work it out. Let me give you an example. Say, suppose I've got a right angle triangle and suppose this is 4 root 3 meters, and I'm just at random giving you an example. This is 30 degree, and say this is, I've named it as ABC, right? So we want to find out the length, say AB. So I'm using tan 30 degrees is equal to 4 root 3 perpendicular over base AB. So tan 30 is 1 by root 3 equals to 4 root 3 by AB, or AB is equal to 4 root 3 multiplied by root 3. Root 3 into root 3, you know 3. So 4 into 3, that is equal to 12 meters. So I've got the length of AB. Now your question is, if I use trigonometric tables. Now, so again from this ratio, I'm coming to this ratio and we are using it. So therefore, tan 30, now look, let me look at the table. Okay, looking at the table, I get tan 30 is 0.5774. This is from the tables. This is equal to AB 4 root 3 perpendicular upon base, that is AB. So AB is equal to 4 root 3. Root 3 is what? 1.732 by 0.5774. Now, huge calculation. I'm just pressing with my calculator and just checking it up. Yes, the value is coming to 11.998, which is not the answer we expect is 12 meter. You'll say rounding off is that. So rounding off, by rounding, you'll be getting your answer, not your exact answer. And look at the amount of calculations we would have required to do it to get to this answer also. So do not use trigonometric tables when they are standard angles. Just use the standard values. Please remember this. Now, what is our next question? Let us have a look at our next question. Yes. After solving a sum, if the answer is an irrational number, may we leave the answer in root form without changing to decimal answer? No, you cannot leave your answer as an irrational number. You have to change it into a decimal value. And also further, if they say rounding off, you must note that and round it off to the required number of places or significant figures. Please remember that. Okay, let us see what is our next question. Okay. In the examination hall, will we be provided with mathematical tables? Yes. You will find in your question paper also written there that mathematical tables are provided. So when you have in the examination hall, always your mathematical tables will be provided to you. So if it is not provided, you will ask, there is the supervising examiner, there is the invigilator, just put up your hand and ask for it, and they will provide you with the mathematical tables, and you can use it to find out angles which are not the standard angles. So don't worry, the tables will be there. What is our next question? So this is our last question. How are angles measured when trigonometry is used to find the height of or distances of tall buildings, trees, etc.? Yes, we use an instrument. There are many instruments used. The instrument that we use is the clinometer. And in my next session tomorrow, I'm going to discuss what is a clinometer and how it is used. So hope all the answers are clear. Thank you very much, all of you, for viewing the program, and hope it has been fruitful and you've understood the basic concepts. And also keep watching, because there will be a lot of sums that we are going to do for tomorrow based on heights and distances. Thank you very much.